Right, this is the green electricity indicator code that I created. To start off, we include the following libraries: the Arduino JSON library, the Wi-Fi library, and the Wi-Fi client secure library. To start off, to use the Wi-Fi, to make the ESP32 used for the project connect to the Wi-Fi, you need to define the Wi-Fi SSS ID or the name and password as constant characters, and you put the Wi-Fi name and password in here. Following that, the servers being used are going to also be defined as constant characters because they're going to be constantly used throughout the code. One is for the smart grid dashboard by AirGrid, and the other one's for an IFTTT applet I created. Following that, a static JSON document is created. This allocates its memory pool in a place, so it allocates the object strings that are going to be deserialized in the code later a dynamic into a memory pool, so it does not rely on a dynamic memory allocation. The strings that are going to be used from the AirGrid Smart Grid dashboard are coal, gas, other, and renew. I will explain how I got these later. Following that, I have three LEDs defined as well to the pins of the ESP32. Floats that I use are going to correspond to the strings that are being deserialized by Arduino JSON. This is so they can be used in the code as an object. The floats for domestic and CO2 are floats that are used to calculate the CO2 intensity on the air grid. And the integer for state, there's the state machine in this code. A state machine use primary data type for number storage. It can't use a float because floats have decimal points, so it needs to be an integer. In the voice setup, I have the LEDs from earlier set as outputs on ESP32. The serial monitor is set up to display the information from the ESP32. Now Wi-Fi.begins initialize the Wi-Fi library set network settings on the ESP32. So SSID and password from before were initialized and the ESP32 will start begin connection to the Wi-Fi. It will display in the serial monitor connecting to the Wi-Fi's name. And this while statement right here will return the status of the connection. So while it's connecting, it will print out dots every 500 milliseconds until it's connected to the Wi-Fi. This is just set in the void setup just to run once. Following that, I set up a void set state. This is going to be used later on in the state machine to go between the different states. So update states variable, and when it does, it will print out the state in the serial monitor. Now, the void update is how the information is going to be got in from the strings before. So the strings, coal, gas, other, renew are all going to be requested in void update. First, we set up the Wi-Fi client set secure as client. This initializes the Wi-Fi client secure library, similar to the Wi-Fi.begin initializes the Wi-Fi library. So if the client is connected to the Wi-Fi, if the client is connected to the server, it will print out connected. If not, this will be false because it's not. Then the else statement will execute. It will print in not connected, and then it will start the connection to server. Wi-Fi dot set insecure means it will skip the verification. So the connection between the server and the ESP32 won't be encrypted. But this has been tested before and no errors have arose. So while the client is connected to the server and 443 is the serial port to make a HTTP connection between the both. This will connection fail. The client will stop, it will delay, then superintending connection failed. This is only if the while statement is true. But the while statement would be false and it will skip on this line of code to this. Now it will say connected to server, which it will be. Then it will start making a HTTPS request. So the client will print in this URL link to get from the dashboard to show you it be getting the information off this page, more specifically the fuel mix. As we see right here, this is updated every 15 minutes. As before, the host is a smart grid dashboard. This is a constant character, so the connection will always be there and up, and then the connection will be closed, and this will all be printed in onto the serial monitor. So while the client is connected, it'll be getting data. So the string to payload is the strings all in the URL. It will read the strings until the very end. That's what the /n is. So it's printing the payload, and the deserialized JSON is when the deserialization of the payload to the strings to use as floats, to the objects to use as floats. So as before, define the floats to the corresponding strings. So coal, gas, other, renew. This is where also the calculation of CO2 intensity is done. So using the floats as units, domestic is all of them coal, gas, other, and renew. Then the energy sources that produce CO2, coal plus gas will be under CO2. So total without export is domestic will be printed out the units of it. Same for CO2. The CO2 intensity is calculated as percentage and it's basically done CO2 over domestic, dividing them. So the client, the ESP32, will keep reading for incoming bytes. That's what while client available is. While the client is available to connect, it will read the strings until end as seen before and write them back into the SP32 into the serial monitor. Now this void for the IFTT underscore post is how the ESP32 sends an email to the user. So it's defined as a string, as it's going to email a word. So for example, this was sent to me on the 9th, and the CO2 intensity level on that day at this time was medium. So it's set up similarly to the void update. We're using initializing the Wi-Fi client secure library. Similar to that, it skips this verification, so the connection is going to not be encrypted, but there was any errors when testing this. Request string is going to be requesting the string here, and the 100 is the characters used. So using this URL I got from webhooks, I took out the API key because everybody gets their individual API key and I don't want to show mine. Then following that by question mark value 1 equals percentage s, which is the string. And the string is obviously intensity. It will do the same, similar to void update, except Arduino JSON is not used in this void. Now come into the loop. First off, the void update is put at the start to get the strings into the objects to use in flows to calculate CO2 intensity. Following that, it initializes the state machine. So if state is equal to 0, it will print out state is equal to 0. On the serial monitor, state 0 is when the CO2 intensity level is high. So this is when it's over 50%. And the red LED will turn on. Then IFTTT underscore post will print high to the email. So it will print out the CO2 intensity level is high. This is done using the applet created in IFTTT. But if if the CO2 intensity level goes down below 50%, it will go into state 1. This is where the set state is. So it's set state to 1, and the CO2 intensity level is medium. So this is between 25% and 50%. And it would turn on the yellow LED and turn off the red LED. So, but if the CO2 intensity level goes below 25%, it would go into state 2, which the CO2 intensity levels are very low. Meaning there's more renewables on the air grid at the moment. Meaning there's more green energy and less CO2 being produced from coal and gas. But if the CO2 and intensity level goes up by 25%, or it increases above 50%, it will go back to state 0, which is this one right here. Why there is an if or option here is if it goes over 25%, it will go back to state 0, then back to state 1. But if it increases suddenly over 50%, it will go back to state 0, meaning the CO2 intensity levels increase to a very high level. A delay function was put in here to not spam the email of the user. So the air grid's updated every 15 minutes, but it takes the ESP32 a minute or two longer. So a 20-minute delay was selected. The code is running at this moment in Comport 5. So at 6:30, these are the units for the total, and these are the units for the coal and gas. As you can see, the CO2 intensity level was 36%. So obviously, it went through state 0. The if statement was true, so it went into state 1, but it wasn't lower than 25%, so this was false, so it stays in state 1. So the yellow LED is on displaying that the CO2 intensity levels are medium. And it displays this on a serial monitor. Now, when state 1 is executed, an email will be sent. So if I scroll down, this message was sent on May 13, 2022 at 6:30, just 6 minutes ago. And it shows the CO2 intensity level is medium. There's two forms of displaying this data on using the ESP32. It displays it using LEDs visually, but if the household owner is out and about or is in a different room to the indicator system, the household owner will get an email to notify them if of the CO2 intensity level, and that's the green electricity indicator.